Welcome back to Outward Home Learning. The subject's computer science, and today we're looking at drawing logic circuits. It's worth mentioning that you should have done the lessons before, which is looking at AND, OR and NOT gates and looking at how logic circuits work before you do this lesson. So now we're going to go to Mr. Holton to tell us more about how we draw them.
Here we go then, drawing logic circuits. These are really good fun. Once you have got the logic in your head of how to do them, you'll be amazed at how quickly you can draw really complex sort of logic circuits. What you'll need for this video, you'll need to understand the logic gates. So please have a look at that video if you haven't seen it already. And you'll probably need to look at the logic circuit video as well, so you understand what we're talking about in the main. Okay, so there's a few different ways of breaking these down, but I follow a simple rule to start off with, and it might sound a bit strange to begin with, but trust me, it will make sense as we do it. This is that the number of words that you have in your expression should equal the number of gates that you draw. And if that doesn't make sense to you, then it will do, and I'll explain it as we're going along. Because by and large, I mean, apart from just forgetting maybe what an AND or OR gate looks like, the next most common mistake I see is students putting in, well, gates just where they're not needed. So that will help you avoid that particular problem. Right, here are the steps that you need to follow then. First thing you need to do is count your AND and OR gates, because you're going to do something slightly differently if you've got one gate, AND or OR gate, or you've got more than one. Okay, so if you have one, AND or OR gate, then you want to draw that first, definitely. And everything else is going to follow on from that. And let's deal with that one first. So I'm going to add on an extra rule here, so I'm going to leave a little bit of space for it in a moment. But let's give you some examples of this. So if you, let's do this one here, A and B. Let's just start off really basic, A and B. That one should be fairly simple. You just need to remember what an AND gate looks like, and that it looks like the letter D there. All right, so that is your, if you get that as a sort of question or something to figure out, then you should be laughing. That shouldn't be too difficult. Gets more complicated when we throw in NOT in the situation though. So let's have like, let's not do AND again. Let's do A or not B. So what do you do here? Well, you should, because we've only got one OR here, so you counted that, we've got one, draw the OR gate first. All right, so if I'm drawing my OR gate first, which I'll do here, and as you know, I cannot draw ORs very well, then I've got two things that go into the OR, and I can just work backwards to that point. So what goes into the OR? So I'm looking at this side first. Well, A goes into the OR, and then I'm looking at this side next, and then it's not B. So then I know I need to draw a NOT gate, which is that thing with a cherry on top, and label that B there. Okay, so that's my diagram for A or not B. Let's just do that the other way around very quickly. Let's do not A and B, and I can do the same thing there. I'm counting, I've got one AND, so that's nice and simple. Do that and then start working my way backwards. So I've got not on the left hand side of this AND gate, I've got not A, so I need to put a NOT gate there. And then on the right hand side I've got B. All right, so far hopefully that sort of makes sense. If you've only got one AND or one OR, draw that first and then work out what the inputs are. So if you have more than one AND or OR gate, then it gets a bit trickier. The key here is to find the middle gate, and to find that middle gate, sometimes you'll have to sort of treat some expressions in brackets as one, and I'm going to just show you by example what I mean by that, and hopefully it'll become a bit clearer. So this is when you get like far more complex sort of logic circuits, and this will be the rough end of what you probably be asked to do. So let's do this one, right? So we've got A and B, or not C. Let's do that one. So we're going to jump in the deep end and have quite a few gates here. One thing that I should have picked up on, I've got an AND, an OR and a NOT. So what I should end up at the end of here is 3 gates that I've drawn. Okay, so now I need to find the middle expression. So what I need to do, anything in brackets I treat as 1. And then this word here I treat as 2. And this I treat as 3. Okay, because this is one expression as well because of the brackets. So my middle gate here is OR, isn't it? So that's the one that I should draw first. I'm going to do my OR gate here. Okay. And then what I need to do is figure out what goes into either side of the gate here. So let's do this top one first. A and B goes into the top of that gate. So if I've got A and B, that means coming into that gate there, I need to do another gate, which is going to be an and then I'm going to do A and B going into that. All right, so A and B is the first part of that. The next part, the other side of that gate is not C. Do you see a not C? So going back here, I'm going to do a NOT gate, and then I'm going to do the cherry on top for that, and then I've got C. So like I said, if you figure out the middle here, so A and B or not C, treating these brackets, sort of anything in brackets as one, then you can draw the middle gate first, and then you can work backwards, and things become a lot easier after that point. I'm just going to throw in a couple of curveballs here that you might get. So one thing that you might get, instead of having nice simple words, is that you might get some expressions, so some symbols. So let's have a quick think of one. You might get something like this. So you might be asked to draw the circuit for this sort of Boolean expression. And what you would need to do there, I should put brackets around that one to make it really clear, is just convert all these symbols to the correct words. Now, if you remember, we've got three expressions. We've got that, which looks like an A, so that's and. That, which is the opposite of and, which is or. And then this one, which does not look like the other two, so that one is not. So remember that one is not, and that one is and. Then you can figure out by process elimination that one is or. So this expression here is actually not A or B. And if you do that and you work to the rules that we had before, that shouldn't actually be too difficult for you to draw. So we've got not A or B. We've only got one AND or OR gate, so we're going to draw that one first, which is here. And then going into that, we've got on one side of it, so the top side here, we've got not A, and then at the bottom of it, on the other side of the OR gate, we've got B. Okay, so that is how we draw that gate. One last gate I'm going to give to you, which I know sometimes throws, some students struggle with, is this one here. So if you have not A and B, how would you draw that? It's an important question, because you've got one and, okay, you've got one and, so you definitely want to start with that first. And then going into that, you've got A and B. Now you might be tempted, and I've seen lots of students sort of make this mistake of doing two nots at this point, because you know you've got a not A and you've got a not B, but that is not how the gate is drawn, because you've added an extra gate. So I have two words, so I should only have two gates overall in this expression. So actually what this should be is a simple AND gate, and then after that you can do this, you can knot both of them. Okay, so don't draw more gates than there are words in the expression. If you follow those rules, and just to recap for them again, make sure you've got the same number of words as you do gates. If you've got one AND or OR gate, draw it first. If you've got more than one, find that middle. With anything with brackets treated as one, then hopefully you can always work backwards and figure out exactly what that gate should look like. And they are good fun when you get to them, so make sure you practice them lots. That is obviously the best way to learn.
So for your first task, you've been given a number of different scenarios, and you need to draw the logic circuit for each of them. It's worth noting that if you copy and paste the symbols, it will make it a little bit easier on this one. So you need to open up that first task, and you've got 10 minutes to complete all three of the scenarios. Off you go. Okay, so hopefully you had enough time to complete that. Now we're going to go to Mr. Barnes to review the answers.
Right, let's have a look at this drawing logic circuits activity. So there's a couple of things we've got to do for each activity or each task. We have to come up with the expression first of all, and then we have to draw that circuit. So let's look at the example first, because that's going to help us with the others. So we've got an example. I will only go to the party. So party is the outcome if Alex and Sam are going, with Alex being A and Sam being S. So what we've got here is P equals A and S. So here in my expression you'll see we've got P equals A, the AND symbol, and then S. So as a logic circuit we've then got the output of P and we've got A and S. Okay, so let's have a go at the next one then. So the missile will be activated, so we've got M equals when the key is turned and the button is pressed. So the key is K, where the key is turned and the button is pressed. So we've got M equals K and B. So if we know we've got the AND gate, we can draw that very simply. And we know the output is M, and we know the inputs are K and B. Okay. Task 2 then, they're going to get a bit trickier now. I will go to the party if Sam is going but not Alex, as I don't get on with him anymore. So our output is P. So if Sam is going, so we've got S, but not Alex. So we've got not Alex. But we're going to have to put something in the middle here. So Sam and not Alex. Okay. So then we need to turn that into a logic circuit. So we've got here not Alex. Well, follow the process. So we find the middle, which is our AND sign. So we're going to have an AND gate somewhere. And on the left hand side of that AND gate we've got Sam. So I'm going to have one input which is just S. And the other side of that AND gate we've got not A. So I'm going to draw another line. I'm going to draw the not. And I'm going to put A. So we've got not A and S equals P. And then last but not least then, we've got I will only go outside. So outside is our output. O equals if it's sunny or I have an umbrella or I have to put the trash out. Okay. So we've got S. Well, the reason it can't be an AND for I have an umbrella and it's sunny is because why would you take an umbrella out if it's sunny? So we've got S, and then we're going to have or U or trash. Okay, now that doesn't look quite right because we're going to need to put some brackets around it first. So sunny or an umbrella are going to come together, because if it's sunny you don't need an umbrella, or you need an umbrella because it's raining, and then the trash is a separate entity. So we've got sunny or umbrella or trash. So then what we need is we've got our output O, we find the middle, which is this one here, which is our or, and I'm going to draw that onto it. Excuse a really bad or drawing, I cannot draw these to save my life. So the right hand side of the or we've got T, and to the left hand side of the or we've got S or U. So I'm going to draw S, I'm going to draw U, they're my two inputs, then I'm going to draw an or onto it, again with a really bad drawing, and then I'm going to connect it up to the other input. So what we've got is we've got S or U or T, and what I would normally do if it's an exam is I'd write the name in because my drawings are so bad, so they know that I want an or gate. And there are your answers for the drawing logic circuits activity.
As always, you've now got an exam question to complete on logic circuits, so give it your very best shot. You'll get a chance to review the answers afterwards, and you're going to get 10 minutes to complete these questions. Off you go. And now finally we're going to go to Mr. Barnes to review those answers. Make sure that you're correcting them as you go if you made any mistakes at all. Over to Mr. Barnes.
Okay, so here we've got some practice questions on how to draw different logic diagrams. We've got it all in Boolean notation. So the first thing I'm going to do is write down and remember what the different ones are. So we've got that, which looks like an A to me, so that's an AND gate. We've got the opposite of the AND gate. Well, not the opposite, but the symbol's the other way around, which looks like a V, which is the OR gate. And then we've got like the little bar thing, which leaves the NOT gate. So they're my three gates. So here we've got R equals A and not B. Now the first thing I do is what's called find the middle. So the middle Boolean operator in this expression is that AND gate. So I'm going to draw my AND gate, just like that. So that is my AND gate. And to the left hand side of my AND gate I've got A. So I'm going to label that A. Now to the right hand side of my AND gate I've got not B. So what that means is I'm going to have to draw a NOT gate and then have B go into it. So I've got A and not B. Let's go on to the next one then. So now I've got A or B and C, but B and C are in brackets. So my middle, as I call it, is the OR gate. So excuse a really bad OR gate drawing. There is my OR gate. So to the one of my inputs to my OR gate, nice and easy, it's just A. Okay, and to the right hand side, or my other input, is B and C. So I'm going to have to draw an AND gate and have B and C going into my AND gate, and the output from my AND gate going into my OR gate. So once again I've got A or B and C. Last one then. So we've got not A or B. So here it doesn't look like there is what I call the middle is easy, so I'm going to go for the brackets and I'm going to draw A or B. So that's A or B, but I want not A or B. So if I put a NOT gate on the end and put E at the other side, I've got not A or B. And I've just realised on these other questions, to make sure they're complete, I should probably label the final output. So that one's R, and then this one is Q. Right, let's have a look at the mark scheme then. So for the first question, as you can see, I've got my NOT gate, and I forgot the little circle on the end, but that's not too much to worry about right now. And then I've got my AND gate. So marks rewarded for an AND gate with two inputs, or a NOT gate with with one input, sorry, and then the correct logic circuit. So I've got the correct logic circuit, so I've got 1 mark, 2 marks, correct. Okay, next one then. So 3 marks available here. So I've got an AND gate with 2 inputs, an OR gate with 2 inputs, and then I've got the correct diagram for a 3rd mark. Now it is probably worth noting that I should have, because some of these gates aren't easy to draw, wrote the name of the gate inside, just so the examiner can't get it wrong of what gate you're trying to draw. And then last but not least, if I move it this way, so I've got not A or B. So here I've got an 1 mark OR gate for 2 inputs, and then 1 mark for the correct diagram. So I've got my my NOT gate at the other side. And there are your answers for drawing logic circuits.
And that's everything you need to know about drawing logic circuits. It's a challenging topic, so if you need to go back through any of these, please do, and we'll see you next time.